In this video, we're going to cover the creation of the base SoundEngine class.
So we're ready to actually program our very first class in this project.
Right, and this will begin our journey on establishing the SoundEngine system we had discussed earlier.
All right, now this is basically going to be a class that we're never really going to call on in and of itself, right?
That's correct. This is actually not only a base class, we're actually going to define this as an abstract base class. The idea here is that no one at any point is ever going to use the actual original SoundEngine.
Right.
Its purpose is to define the method interface that all sound engines are going to share.
See, I like to think of it like this kind of open-ended machine that we're building that really just has a whole bunch of brackets hanging on the walls with nothing in the brackets yet. And we've got some other components we're going to hang on the brackets later on.
Right. It's built in a sense so that later on in time those can be implemented and therefore we can plug in functionality to all of these open brackets.
Let's do it!
All right, to get things started, we're going to clean up our view here a little bit. I'm going to, let's see, we'll minimize this content subproject, collapse all that down, give ourselves some room to work with. And
Make
then
a
we'll
new class.
Right-click on our project, SoundEngine, and we'll add a new class. And we'll call this class SoundEngine.
We won't add a new about box.
Yes, that would be less than favorable. We'll make sure that we are indeed adding a class.
Yeah.
So SoundEngine, we'll add that in. This results in SoundEngine.cs, and we have our class. Now, before we jump into the class itself, I do want to add a using statement just to open up the Microsoft XNA framework namespace, since we're going to be using the game type held within. So our using will be Microsoft.xna.framework.
Cool.
All right. Now, turning our attention to SoundEngine, the very first thing we're going to address is the fact that this will be an abstract class. As once again, we're going to make sure that we never make the mistake of instantiating an empty, non-functional SoundEngine.
Yeah, it's like instantiating the chassis of a car. There's just nothing in it yet.
Yeah, not in terms of drivability. You wouldn't exactly grab your chassis to go driving down the interstate.
Exactly. Be a little ill-prepared.
All right, so let's talk about some methods. This is going to be the core interface that all SoundEngines will use. Now, I'm going to describe these as I drop them in place, so let's just begin from the top with our initialize method. All of these methods that we're going to lay in here into SoundEngine are going to be both public and virtual.
Okay.
Public, obviously, so that they form the public interface of the class, and virtual so that we can override their functionality in more specific sound engines.
Right, so with one API, the initialize may have a certain set of functionality. In another sound API, it may have a different set of functionality altogether.
Exactly, because who knows what's actually going to need to be done to satisfy any specific actual API.
Gotcha.
All right, so to begin here, we've got public, virtual, void, initialize. Now the initialize method is going to take in a game instance. So we'll specify a parameter of type game, and we'll just call that game. Now, we're not going to specify any actual code for the implementation of any of these methods. Again, the base SoundEngine isn't even usable by itself, and there is no APIs we are linking up to yet, therefore we'll have no actual code. So I'm just going to drop the brackets, the method body, to our method right out here to the side, just to save on space.
Sure. Now, again, these are just kind of like open brackets on the wall into which we're going to plug in some functionality later on.
All right. Now, the initialize method itself, the purpose of this method is to allow the game engine in question to set up whatever API stuff it needs to do to get itself ready for use.
Right.
That's going to include maybe talking to a device, getting a device ready to use. It all depends on the actual API in question.
Right. Well, the big thing it looks like it's performing here is whatever is going on inside of initialize, we're passing the game into it. So now we can talk to and handle the game directly.
That's true. We are also giving ourselves the ability to look back and see the current game instance, and this may be useful for getting things like environment information, just expanding our view of what we can hand off to any other APIs that need initializing.
Okay.
All right, moving on from here. The next method we're going to address is unload, and it is also going to be both public and virtual. We will have no return, so our return type is void, and the method is called unload.
Now, I know the answer before I even ask it, but is there really any purpose behind the order in which you've put these in?
There is not, just for whatever is most convenient for readability, or convenient for readability.
All right. I mean, I know. I'm just checking to make sure anybody's curious. Like, do you have to put unload after initialize?
It's just a form of structure. As a matter of fact, we're even free to change this up a little bit, since some of the sound engines may not even need to use the unload method.
Yeah.
And again, the purpose of unload is just in case any given sound engine allocates or gains access to any external handle or device or file. This gives the sound engine the opportunity to clean up any of those associations or data.
Sure.
All right, moving on from here. We have, once again, a public virtual void method. This time we are going to address load sound. And load sound is going to take in a parameter. It will be a string named sound name. Alright, the idea here with load sound is that we need a way to tell our sound engine to load up some actual sounds.
Sure.
And also, we're going to try and keep our sound engines as clean as possible from the standpoint of files and path information.
Mm-hmm.
The idea is that we don't want to have to worry about our sound engine looking at the environment, be a file system or maybe an exact project, an audio project. We want to keep this as simple as possible so that load sound is merely an individual sound to be loaded up.
So we're explicitly telling it exactly what sounds to load.
Exactly. This offloads the burden of finding paths and files to whatever is calling the sound engine load. Generally, this will be our XNA's game, and that's also the place where you're dealing with things like the content manager, its paths, and any other paths you need. So really, that would be a cleaner place for path information to live.
Right.
And that way we'll pass in a fully formed file path directly to load sound and not have to worry about it.
Instead of just saying
inside
grab
here.
everything found on this path.
Exactly. All right, moving on, we have the update method. Once again, this will be public, virtual, no return, and it will be called update.
Now, in at least one of the APIs, this one tickles me a little bit.
Yes, this one is just in case our given audio API requires periodic updates.
And one of them will.
And yes, one of them will. The idea here is just since we have a source of periodic updates in any given game, we
Sure.
can just use the update method and get many concurrent updates. We simply give ourselves the ability to pass that notification along so that any given sound API can be notified of the fact that time has passed.
Yeah. Very simple.
All right, the last method we need to address
Probably the
is
most important in a sound engine.
the play method. So we have public virtual void play. Now play is going to take in a number, an integer called index. Let's talk about this a little bit. Obviously, this is going to be the method that will cause our sound engine to actually play sound.
Yeah, and at first you'd be thinking, well, up with load sound, just a second ago, we were taking in a sound name, so, I mean, off the top of your head, at least I know I would probably be thinking, well, why don't we just play based on sound name too?
Exactly. Why not take in a string into play and play by name instead of by index?
Yeah.
The reason is because, in this case, while SoundEngine is meant to be generally modular, it is being designed targeted at the drum game.
Okay.
The drum game is going to handle tracks, or different drum tracks, as individual indexed numbers.
Right.
The idea is each track will be assigned a number,
Right.
and therefore it would be convenient if the sound engines were based on the same system.
Right, and this calls back to the kind of game that Drum Game is, which is very similar to games like Guitar Hero and Rock Band, where each track of gameplay basically is assigned a specific instrument, and you're going to be calling one specific sound per track.
That's
So
right.
what we've done is we've just kind of taken one extra step that we're going to need later on anyway, and we'll be calling these sounds not by their name, but you could think of it as the track to which they're going to be assigned in the game.
Exactly. That way, that just eases any necessary conversions or lookups. If
Right.
the sound engine is from its inception designed to play by index, that means if we play indexed tracks later,
Yeah.
then all the numbers simply line up. All right. Now with that, we can simply build to make sure that there's no syntax errors. Everything is looking clean. And really, that is all we need for our base sound engine.
It doesn't do anything yet, but it looks fancy.
But yes, once again, here we can now see it. We have our public interface put in place for the sound engine, and we can now begin working on individual sound engines for specific APIs.
So yeah, this right here is the core of our system that allows us to have multiple APIs for our sound engine, just by having this abstract class that we can call into and then put our own functionality on a per API basis.
Exactly.
Very cool.
So with that, that's going to wrap up this video.